Hi everyone, welcome back to my tutorial on how to make your first video game. In this installment, we'll be adding the ability to shoot bullets from our ship and make them disappear when we want them to. We're going to be doing a lot of work that seems like overkill now, but getting it set up well at the beginning will make the next steps a lot easier. It's really easy to fall into a pattern where you keep doing only the fun parts of game development without worrying about how different pieces will go together and how expandable or scalable your system is. And when you do, it becomes really difficult to connect all those different pieces. Regardless of the tools you're using, you'll want to make sure the code that you write makes a solid base for other features you add in the future. I'll be introducing a few more programming concepts in this installment, so don't feel bad if you need to play through certain sections multiple times to fully understand what's going on. Getting a full understanding is really important. After this, though, we will have covered every basic concept we'll be using in our code for this series. Everything else will be built using these tools. So let's get started. The first thing we're going to do is create a new file to handle our bullets. I'm going to call it bullet.js, and we're going to add a constructor function for a bullet object. This is going to take in 3 parameters, an X position, a Y position, and a direction. The direction is going to be how we tell bullets being shot by the player and bullets being shot by the enemies apart. Our player is always going to shoot up, and enemies are always going to shoot down, so this value is all we need to tell the two apart. When a bullet is shot by the player, it'll have a direction of -1, because it's going up the screen, and when one is shot by the enemy, it'll have a direction of 1. Now that we have our parameters defined, we need to add some properties to our bullet object. We'll save the X and Y parameters with their own respective properties, and we'll do the same thing for our direction value. We're also going to need a width and height value. For this simple prototype, all bullets are going to be the same size, so we can hardcode these values rather than having parameters to define them. I'm going to set the width to 6 and the height to 20. We're also going to need a speed value to determine how fast our bullet is moving, which again will always be the same, at least for now, so we can hardcode this at 200. Just like our player object, our bullet is going to have a draw function and an update function. For now, the draw function is going to be identical to the one on the player, so we can just take this, copy and paste it over here. The update function is going to be a little different though. We're going to pass in the DT value like we did before, but we're also going to add an index value. It's going to be important when we're handling other things with the bullets that we know exactly which bullet we're referring to at a given time, so this will assign each of them a number so we can tell them all apart. In our update function, all we need to do for now is move our bullet either up or down based on our direction. So the only line we need here is this.y plus equals this.speed divided by dt times this.direction. Now, if our bullet is shot by the player, meaning its direction is -1, it'll flip our speed value so that the bullet travels up. And if it was shot by the enemy, the direction will be 1, so nothing will change. To make it so that our player can shoot bullets, there's a few things we need to add. The first thing is adding a button on the keyboard that the user can press to shoot a bullet. To do that, let's go to input.js and add a new input to our inputs object called shoot. In our key bindings, we can set this input to any key we want. I'll set it to spacebar, which has a key code of 32. Now, let's go to our player file and handle this input. We implemented our input system to only track whether a button is pressed or not. We don't have any way of knowing the moment a button is pressed. I don't want the player to be able to just hold down spacebar and shoot automatically, so we're going to need a little more logic to add to our player so that a bullet only gets fired on the first frame the spacebar is being held down, and another bullet can't be fired until the spacebar is released. We can accomplish this by adding a Boolean property to our player, which I'll call shotlock. We'll first check to see if spacebar is being pressed using an if statement in the same way that we check for the left and right inputs. Now we need to combine inputs.shoot with this.shotlock to make sure we're only shooting a bullet if this.shotlock is false and inputs.shoot is true. To make this happen, we can combine multiple Boolean values together using Boolean operators. These operators let us manipulate the Boolean values we already have and combine them to get a single value of either true or false as a result. There are 3 basic Boolean operators, and, or, and not, and they're represented in JavaScript with these symbols. Not is the simplest of the 3, which just gives us the opposite of a Boolean value. If inputs.shotlock is true, then not inputs.shotlock, with not being represented as an exclamation point, would be false. And or combine 2 different Booleans together based on their values. And requires that both Booleans are true for the result to be true, and otherwise it'll be false. Or will be true if one or both Booleans are true, so it's only false if both are false. So inside the parentheses of our if statement, we're going to say inputs.shoot and not this.shotlock. We want this block of code to execute if the player is holding down the spacebar, but they haven't already fired a bullet. I'm going to add another function to our player to handle firing a bullet, called this.shoot. Down here, we'll actually handle firing the bullet, and to do that, we're going to be creating a new bullet object. Let's make a variable to store this new bullet. I'll just call it B. And just like our player, we can make a new bullet object using the new keyword and then calling our bullet constructor function. We need to pass in the bullet's starting X and Y positions, as well as its direction. We can pass the X and Y of our player using this.x and this.y, but this will spawn the bullet in the very center of our ship. To add a little more precision, let's adjust the Y value so the bullet is fired from the front of the ship rather than the center by subtracting half of our player's height. Finally, we'll pass in a direction of -1 because the bullets our player shoots go up the screen. So now we have a bullet we've created, and just like our player, we need to call its draw and update functions inside the game loop in index.js. Because the player can fire as many bullets as they want, we can't have just one variable to store the bullet. And we have no way of knowing how many bullets are going to be on the screen at any given time, especially because the enemies are going to be firing too. So, we're going to use something called an array to store all the bullets that both the player and the enemies shoot. An array is basically just a list of values, stored in a certain order that we can individually reference by using that value's number in the list as an index. Typically, these index values will actually start at 0 rather than 1 across almost all programming languages. This has its roots in lower-level languages, where understanding how memory is allocated for variables is important. Arrays in these languages are usually of a fixed length and only store one kind of value, like an integer, and the compiler will know how big an integer is and allocate a block of memory split up into individual sections for each element of the array. You could then use the index to say how far away from the start of the block of memory your element was. Because the first element started right at the beginning of the memory block, it was 0 elements away. And even though modern, high-level languages like JavaScript handle arrays in a very different way and allow for arrays of dynamic lengths and non-uniform types, they typically maintain the precedent that indexing starts at 0 instead of 1. So let's go back to our index.js file, and we're going to add an array to store our bullets. Rather than calling this bullets though, I'm going to call it gameObjects, because this array will also store all our enemies. Arrays are defined using square brackets, and you can fill in these brackets with as many elements as you want, separated by commas. We don't want to start with anything on the screen other than the player though, so we'll leave this empty for now. We aren't going to know at any given time how many bullets and enemies are on the screen, but we still want to call our draw and update functions on each of them every frame. So we're going to look through our array every frame by iterating through the array with a for loop. Loops are blocks of code designed to be executed over and over again until a certain condition is met. When you start writing a for loop, it looks really similar to an if statement, but inside the for loop's parentheses, we're going to need 3 different statements, separated by semicolons. The first sets a variable that will be used by the other 2 statements. Conventionally, this is a variable just called I, because it acts as an index of the loop. The second statement is a condition that has to be true for the loop to keep going. As soon as this statement is false, the loop stops repeating. The third statement is used to make sure the loop actually does end eventually, typically by increasing the index with each iteration of the loop so it meets the end condition. One of the most common uses of a for loop, which is also the way we're using it, is to increment an integer value by 1 with each iteration of the loop and have an end condition that an integer is at a certain value, and a lot of times that value will be the length of an array. This allows us to call the same block of code on each item in our array, using the I value to determine which item in the array we're currently working with. Here, we'll have a condition that runs through the loop until the value of I hits the length of our gameObjects array, which we can find by typing gameObjects.length. The third statement increments the value. If you remember in part 1, there's a shorthand operator you could use to add 1 to this index value, the plus equals operator. But because this specific use of plus equals is so common, there's an even more concise shorthand operator that just increments the value by 1, the plus plus operator. This is how C++ got its name, saying that the language is basically one-upping the original C language. This is probably the most common use case of a for loop, and we'll definitely be adding more just like it as the series goes on, so try to get used to how this looks and what each part does. Inside the curly brackets of our for loop, we have access to our I value, which we can use to reference individual elements of the gameObjects array. The syntax for this is the same as the syntax we used in input.js for our inputs and key bindings objects, but instead of the names of properties on objects, we pass in our index value to retrieve the element of the gameObjects array at that index. Now, we can just call our draw function normally. We'll do the same thing for the update function, But if you remember, we have to pass in not only our DT value, but also an index value, which we can now use as I. Now we have a system in place to handle as many bullets as we want with our array, so we just need to add the new bullet in our shoot function in player.js to our array. To do that, we can use a built-in array function called push that takes the value to add to the array as a parameter. The functions to add and remove values from arrays have names that aren't very straightforward, so a good way to remember push is that it pushes the new value all the way to the end of the array. The last thing we need to do in our shoot function is set the value of shot lock to true, so that our player can't spam bullets once every frame. But now the player can only shoot one bullet before it's locked out, so we need a way of resetting the value of shot lock so our player can continue. This is as simple as adding an if statement on our update function that checks if the player isn't currently holding spacebar, and if they aren't, we can set shot lock to false. And before we forget, we still need to have our call to this.shoot in here, and it looks like I've got a little bit of a typo here. JavaScript is case sensitive, so always make sure that all of your names are correctly capitalized. But now, with our shoot function being called and shot lock being set to true and then false, we can save all our files and remember to add our bullets.js file in our index.html. Now, we can open up our server and now, not only can we move left and right, we can use the spacebar to shoot bullets. One thing to keep in mind though is that just because the bullets aren't on screen anymore doesn't mean that the game isn't still trying to draw them and update them. We need to add a check to prevent these bullets from traveling off into the void above our playfield and always taking up an iteration of our for loop. As we get further into the game though, bullets aren't going to be the only things that we're going to want to remove after they go off screen, so rather than just adding this function directly into our bullet.js file, I'm going to make a new file called utils.js. This file will have various useful functions that multiple objects in our game will use. We're going to make a function called out-of-bounds, and it's going to return a Boolean value. We've already used functions like the update and draw functions on our player in bullets, but these functions don't take advantage of one of the main things the functions can do, return values. If you think back to how mathematical functions were described in your algebra class, the same idea applies here. A mathematical function takes in some inputs. If we're graphing on a 2D plane, that's usually just the x value. The function will then take that input and give an output, usually the y value of a point on the graph. In the same way, functions in our code can take in one or more inputs and then return an output, but these values aren't limited to just numbers. We could take the simple x squared example we did on the graph and apply it to code, and you can see that it translates pretty seamlessly. Our out-of-bounds function isn't going to return a number though, it's going to return a Boolean that will be true if the bullet or any other game object passed in as a parameter is outside of the boundaries of the game's canvas. We're going to be passing in our bullet as a parameter, but we'll generalize its name so that when we use this function for other things in the future, it still makes sense. We can think about the x and y directions separately, and handle both of these conditions on their own. The object will be outside the bounds of the canvas in the x direction if its x value is less than 0 or greater than the width of the canvas. In the same way, if the object's y value is less than 0 or greater than the height of the canvas, it's out of bounds. These four conditions can be combined to make one Boolean expression using the Boolean operators we talked about earlier. We want this condition to be true if any one of these four scenarios is met, so we can connect all four of these Booleans with ORs. Another thing to consider, though, is that if we're only waiting for the object center to hit the edge of the screen before we delete it, the other half of the object will suddenly disappear while still on screen. This isn't a huge deal for the bullet, but we're going to be using the same function to warp our player from one side of the screen to the other later on. So on each of these four conditions, we're going to add or subtract half of the object's width or height so that in each direction, we're waiting for the object to be fully off screen before we consider it out of bounds. When you have a really long line like this, it usually helps to break it up into little sections so that it's a lot easier to read. Before we can use this function to handle these scenarios, we need to lay a little more groundwork for a system that will handle removing game objects when we don't want them on the screen anymore. This way, when we add enemies in the next episode, we'll already have a system in place to handle removing them when they die. In our index.js file, right below our game objects array, Let's make a new one and call it objects to remove. And again, start out blank. This array will have a list of indices for objects in the array of game objects that are ready to be removed from the list. And when our game loop function runs every frame, we can check if there are any values in this list, and if there are, we'll remove the objects at those indices in the game objects list. To do that, we're going to go into our game loop function and add a new kind of loop, a while loop. A while loop is similar to a for loop in that it runs until a certain condition is met. So long as the condition in the parentheses of a while loop is true, the loop will continue to execute. This is how infinite loops occur. If the condition in the while loop is true and never becomes false, there's no way to end the loop and our game would have some issues. In our game though, we'll be using a very simple loop that shouldn't cause any errors like that. But make sure you don't try and test the game until you've written out the whole loop, or you might get an infinite loop. The condition we'll be checking against is whether objects to remove that length is greater than 0. Basically, checking to see if there are any objects left to remove. If there are, we're going to use the index value we have stored in our objects to remove array to remove it from the main game objects array. Arrays have built-in functions to add or remove the first and last items in arrays, but we want to be able to remove any item from the array based on its index. So we're going to use the splice function. The splice function takes in 2 arguments, the first being the index we want to start removing items at, and the second being the number of items we want to remove, which will just be 1 for us. A straightforward way to do this would be to just get the first item in our objects to remove array, splice the game objects array there, and then remove that index from objects to remove. But if you think about it, we might run into some issues if we have multiple objects we're trying to remove. After we splice the game objects array, there's a gap where that item used to be, so everything shifts over 1 slot, and everything after that item in the array now has a different index, 1 lower than it was before. So if we try to remove the item at index 5 after having already removed another item, we'll actually be removing the item that was originally at index 6. There's a few different ways to handle this, but the one I prefer, because it makes the most sense to me, is to just go through the array backwards. Now, as items are spliced and indices are shifted, all those changes are happening in an area we've already checked, so they won't impact our ability to remove whichever items we want. To go through our array backwards, rather than picking objects to remove 0 in the while loop, we'll pick the last item, which will have an index of objects to remove .length -1 because of 0-based indexing. Now we have to remove that index from our objects to remove array so the loop can keep going forward. So we'll use the built-in function to remove the last item from the array, which is the pop function. And now all that's left to do is to call these functions so they can work when they're supposed to. Let's go to the update function of our bullet object and add an if statement that checks if the bullet is out of bounds by passing this keyword as a parameter. If it is out of bounds, we want to add our bullet to the objects to remove array, so we'll call the push function and pass in the index of this bullet. With this in place, we'll be able to remove bullets from the game as they go off screen so they won't be messing anything up after they're gone. If we go back and run this again, it isn't really going to look any different, but if I add a counter on the screen that tells you how many objects are in the game objects array, it for this tutorial. If you want to check out the source code for this tutorial, follow the link in the description to my GitHub repository, go to the part 2 branch, and you'll see all the code in its exact state in this video, and then you can just hit this clone or download up here, and then download a zip of it. Next time, we'll talk about adding enemies and giving them a little bit of AI so they can fire back at our player, and we'll make our bullets damage the player and the enemies when they get hit. A lot of the work this time was work that'll be useful not only in this part, but also multiple other parts in the future, so it may seem like the pace is moving a bit slowly, but things are going to pick up a bit in the next one. Also, at this point, I've explained basically all of the programming concepts I'll be using in this series. So if you're very new and still confused, I'd recommend going back and watching the parts where I explain some of the basics and making sure you fully understand those. Things are going to be picking up a bit from here now that all the basics have been covered, which I'm sure will come as a relief for people who do have some programming knowledge. Either way, you're one step closer to making your first game. Thanks so much for watching, and I'll see you next time.